Okay, our objective today before we go over the warm-up is to divide fractions and mixed numbers. I'll come back to this when we get to our notes. Okay, so here was our warm-up. We're going to go through these together, and then I'll have someone tell us what you got for the answer. So number one, first thing that you need to make sure that you do is cross-simplify if you're able to. The 4 and the 16 here, 4 goes into both of them. 4 divided by 4 is 1. 16 divided by 4 is 4. Is there anything else on here that we can cross-simplify? You guys just give me a head nod this way or this way. Is there anything else that we can cross-simplify? Drew, what else do you think? Okay, good. No, there's nothing else we can cross-simplify. So my next question is, when you're multiplying across the top, across the bottom, who can remind us when you're multiplying same base, what happens to exponents? Amberly? Good. So multiply same base, which means if they're both x's or both y's, you're adding the exponents. What is the exponent on this x? Just as a reminder for today's lesson and for this. Grace? Good. There's really a 1 here, and then same with this y. So when you multiply across the top, across the bottom, 1 times 2, or 1x cubed times 2x, I should say, is 2x to the 4th. X to the 3rd times x to the 1st is x to the 4th. Okay? And then 9 times 4 is 36. And then y squared times y is y to the 3rd. Is everyone okay with what we just multiplied across the top, across the bottom? Right? You thought the 6 was a b. Okay, that's my fault, my messy writing. You're good. Just check it the way that you have it if that's what you thought. Okay, now one more step. Yes, we cross-simplified completely, but the fraction, which are our coefficients here, can actually be simplified further. So 2 over 36 can change to what, Mike? Good, 1/18. Now, sometimes that'll happen because this is just like reducing our fractions normally, like we did in lesson 5-1. Okay? Don't forget, you may do that on your calculator if they're larger numbers, or you may just do it mentally. It's your call. Okay, so there's our completely simplified answer for number 1. Questions on 1? Okay, number 2, we can cross-simplify here. Nathan S., can you tell us one thing that we can cross-simplify on number 2? Okay, what goes into both of those? Good. And what's the 3 going to change to? Good. And the 21 is going to change to? Good job. Greta, what else can we cross-simplify? Good job. And what goes into each of them? Good. So this is going to change to a 2, and this is going to change to a 9. So after we cross-simplify, in that expression, what are we doing first? Are we multiplying or subtracting first? Skylar? Good, multiplying. Order of operations tells us take care of grouping symbols, then exponents, then multiply, divide from left to right, then add, subtract from left to right. Okay? So when we multiply across the top, across the bottom, 1 times 9 is 9. 2 times 7 is 14. Rewrite minus negative 2/3. Okay, what's the next major thing I always have you do that we always do together? Camille? Good. 2 negatives back to back makes a positive. So I would immediately change that at this step to a plus. So you're really adding fractions with unlike denominators. Okay? So next step is we need to find a common denominator. What is a common denominator or the least common denominator between 14 and 3? Grace? Good job. 42 is our least common denominator, or you could just say the common denominator. David, what does the first fraction become once we change the denominator to 42? Good job, 27. And Evan, what does the second denominator or numerator become? Good job, 28. So here's, you guys should have 27 over 42 plus 28 over 42. Once you add across the top, bottom, Joseph, what did you get for your next step? You didn't get to that problem? Okay. Drew, what did you get once you added across the top, across the bottom? Over. Good job. And then one more step. Did anyone change it to a mixed number? Okay, Mike, what did you get? Good. 1 and 13 over 42. So there's our answer for number 2. Any questions on any part of that? Much, much better than a couple days ago on that. So good job. Joseph, you might want to be writing these down so you have them as practice problems. Okay, number 3 is not too bad. What do you do here? What's our first step, our first goal here? What's our first goal? Kevin, what's the first thing that you did on number 3? Okay, good. So did you find a common denominator? Good job. So once you try to find a common denominator, you should be able to find one. In this case, it's 35. Jackie, what is the numerator change to on this one? Good, 20x. And then Ray, what is the numerator change to on this one? Good, 56x. So when you have fractions with like denominators and there's an x in the numerator, please make sure when you're adding or subtracting, you do not add exponents. Leave the variable like it is. Okay? Nathan S., after you subtracted, what was your fraction? Good job. Negative 36x over 35. Please leave it like that. There's a variable in the numerator and not on the denominator, so don't convert it to a mixed number. Okay? All right, one more. Now, this one, some of you guys were getting yourselves confused because you used base times height divided by 2. On a problem like this, I would use 1/2 base times height. You'll save yourself a headache, at least until we get to today's lesson. Camille? Okay. Yeah, and it's the exact same thing. Okay, well I'll do it both ways because you should still get the same answer. Like if you guys didn't hear Camille, if you're dividing by 2, if you do base times height divided by 2, that's the same thing as base times height times 1/2. Because when you're dividing, change it to multiplication and then flip the second number, which would be our 2 in this case. Either way is fine, but that's actually today's lesson. That's why I prefer that you do it this way until we get through today's notes. Okay, so 1/2 base times height. First step here, Michelle, the base becomes what improper fraction? 4 3/10 becomes what improper fraction? Good job, 43 over 10. And then Mike, the height becomes what improper fraction? Good, 10 over 3. So we now have an expression. You need to multiply left to right, okay? So the easiest thing to do is just take your 1/2 times 43 over 10. We have 43 over 20 times 10 thirds. Okay, so doing it this way, there's the first step. Steve, can we cross simplify anything? Okay, what can we cross simplify? Good job. 10 goes into 10 one time. 20 divided by 10 is 2. At this point, is there anything else that we can cross simplify? No. Multiply across the top, across the bottom. 43 times 1 is 43. 2 times 3 is 6. So there's your answer. We can change that to a mixed number. Nathan M., what mixed number does this become? Close. Not 1/2. 7 and 1. What denominator do you always keep? Good. 7 and 1, 6. When you guys are converting it back, please make sure you remember you always use this denominator. Okay? Mike. Okay, did you do it the way Camille said? Don't know? Okay, well, we're going to get to that in 1 second. Okay? Before I do it the other way, questions on this way. Camille. Where'd I get the 20? Okay. So when you multiply up here, you want to multiply from left to right. So 1 times 43 is 43. 2 times 10 is 20. Remember, order of operations, multiply from left to right. So then I basically just rewrote this term. Does that make sense? Is that where you made your mistake? Okay. Evan. Not really, but we should stick to order of operations all the time just so we're all consistent. Did you do it a different way and you got the same answer? Yeah, you're okay. Just we'll try to do it from left to right all the time. That way we're not making any silly mistakes ever. Anyone else have questions? Mike, do you want me to show you the other way? Okay. Okay, so our other way here is taking base times height and then dividing by 2. So our improper fractions were 4 thirds over 10 and 10 thirds, 10 over 3. So base times height, you did all divided by 2, right? You didn't write it that way? How'd you write it? Okay, okay. Raise your hand if anyone else, if you did it this way, raise your hand if you divided by 2 instead of multiplying by 1/2. Okay, so Mike, you still should have taken your 10s, cross-simplified, right? So you have 43 over 3, and then you divided by 2, right? Okay, I would leave it as improper. You're going to create more work for yourself if you change it to a mixed number at this point. Okay? When you divide it by 2, did you put it over 2 or did you do divided by 2? The division symbol. How did you change it to 14 over 3? Okay, I want you to keep it as an improper fraction though. Okay? Because then you're going to have to, if you change it to a mixed number, you have to convert it back to an improper fraction. And you're going to create more work for yourself. You know what I mean? Okay, when you're dividing, this is today's lesson, you're going to change it to multiplication and then flip the second number. So the 2 is going to flip to 1/2. 43 times 1 is 43. 3 times 2 is 6. You still end up with 7 1/6. Okay? This is today's lesson, so that's why I wanted to kind of start with that, leading into that. Okay, anyone else questions on either way or anything on the warm-up? Okay, let's open up your notes to next lesson, which is 5.5. It is page, well, the page that we're starting on is page 15. So it starts off with, it has the word reciprocal at the top. So in your note packet, page 15. So again, those area problems, technically we've only done them by doing 1/2 times base times height. Today's lesson will really lead into, well, how do you divide? If you want to do base times height divided by 2, how do you divide fractions? How do you divide mixed numbers? You've learned this in the past. Of course, they're going to get harder. Your book throws variables in, rules of exponents. Okay, so divide fractions and mixed numbers. The objective is on page 14 in your notes, but we already did the warm-up on that page. That's why we're starting on page 15. Okay, is everyone with me? I'll wait till some of you guys write down the warm-up. Greta? It is on yours. On your, okay. Is that for everyone? Thank you. Mine is on 15. Okay, sorry. Start on 14. I don't know why my note packet's a little bit different. Your definition of reciprocal is on page 14. Thank you, Greta. Okay. Okay, you guys ready? Okay, so first definition, and then we're going to do a lot of examples with this. Okay, so a reciprocal definition from your book is 2 non-zero numbers whose product is 1 are reciprocals. 2 non-zero numbers whose product is 1 are reciprocals. For example, if we have 1 over 2 times 2 over 1, we're going to end up getting 1, right? We're going to get a product of 1 because we're multiplying reciprocals. Don't flip the page yet because I want to give you an example. So your book uses the word reciprocal a lot in this lesson as well as in the next 2. Okay, oh, I didn't realize that was up there. Okay, the example I just said is up there. So underneath that, I'd like you to write an example down. Here's a great example of the product of 2 fractions or 2 numbers whose product is 1. These numbers are reciprocals of each other, okay? 1/2 times 2 over 1. If you flip this, you get 2 over 1. The product is 1. Technically, you could cross simplify. 2 divided by 2 is 1. 2 divided by 2 is 1. 1 times 1 is 1. 1 times 1 is 1. Okay, Drew? Correct. You could also multiply like it is. As Drew said, you get 2 divided by 2, which is 1. I'm just trying to use our cross simplification rules, but you're exactly right. Nathan? Yes, and we're getting to that. Thank you for noticing that. Okay, and then one other example, -3 times -1/3. Now, really, any whole number, which you guys and girls all know, there's always a 1 underneath it. So -3's reciprocal is -1/3. To flip -3, you get -1/3. If you multiply across the top, across the bottom, you're going to get -3 divided by -3, which is +1. You may also cross simplify. Okay? See if you're paying attention, right? Okay, so another question for you. What is the reciprocal of 4? What is the reciprocal of 4? Ben? Good, 1/4. What is the reciprocal of -8? What is the reciprocal of -8? Alexis? Good, -1/8. What is the reciprocal of 3 over 2? What is the reciprocal of 3 over 2? Neil? Good, 2/3. Okay, what is the reciprocal of 1? It's the reciprocal of 1, Ben? Okay, 1 or 1 over 1, right? Nothing's really changing there. So a reciprocal is when you flip a number, flip a fraction. Okay, Steve? Yeah, can be any number. I could give you a whole number and say, what's the reciprocal of 2? You would tell me 1/2, because any whole number has a 1 on the bottom. You remember that from the beginning of the year? Okay. Anyone else? Questions or comments on reciprocal? Evan? Just really nothing, because you can't take anything times 0 is going to be 0. So that doesn't fit the definition of reciprocal. The product of two non-zero numbers, which is up there, okay, it has to be 1. 0 times anything is 0. That's like our 0 product property of multiplication. So completely different. Kind of like, Evan, we talked about prime and composite. The definition is the number is greater than 1. 1 is neither prime nor composite. Just like 0 doesn't work here. Good question. Anyone else? You guys are really thinking outside the box today. Good job. Okay, here's a definition from your book, okay, to tell you how to use reciprocal to divide. So here's what your book says. I just converted it to your note packet. To divide by any non-zero number. So to divide by any non-zero number, that includes fractions, that includes mixed numbers, you need to multiply by its reciprocal. You need to multiply by its reciprocal. After you write that, I want you to write above, next to, or underneath that, keep, change, flip. One of your elementary school teachers teaches it this way. Have you guys ever heard of keep, change, flip? Okay. Last year, someone told me that their teachers always use that, and I really like that. So that was not my idea. I will not take credit for that. One of the elementary teachers, maybe a few of them, always use keep, change, flip. I will explain that once we get to an example. Bless you. Okay, so first example using numbers, okay, from your book. We have 2/9 divided by 3/7. 2/9 divided by 3/7. So example from your book, then, here's how you convert this to multiplication. When you're dividing numbers or fractions, you need to keep the first fraction, so we're rewriting 2/9. You need to change the operation from division to multiplication, and then you need to flip the second fraction or second number. 3/7 becomes the reciprocal. The reciprocal of 3/7 is 7/3. Is everyone with me on keep, change, flip? Do you understand that, Neil? You are dividing, but the rule for dividing is keep, change, flip. That's how you divide fractions. So, Neil, you are dividing, but this is just how you do it. It's like the formula. Kind of like how we change the repeating decimals to fractions. Amberly and Mike. Okay. All right, and then there's no cross simplification that can be done here, so multiply across the top, across the bottom, you get 14/27. Okay, and then an example using variables. Of course, your book loves using algebra, right? Variables. So A over B divided by C over D. When you guys go to college, if you major in math or anything, you can ask Miss Wingrove or myself. You'll do a lot of proofs with variables, and it gets very confusing. So this shouldn't be too bad for you. Okay, so A over B divided by C over D is equal to, rewrite the first fraction, so keep, change the operation from division to multiplication, flip the second fraction or number. So C, bless you, C over D becomes D over C. Lots of sneezy people in here today, huh? Equals, there's nothing to cross simplify. All the variables the book chose are different. A times D is AD. Remember, when you multiply variables that are different, just mush them all together. That's what I said at the beginning of the year. B times C is BC. Your denominator cannot be 0. So you need to make sure you say that B, C, and D, because D was a denominator here, cannot be 0. Okay, Neil? A could be 0. Yep. Grace? Yes. Now, that's okay, though. You can multiply things and end up getting 0, but when you're finding the reciprocal, if you multiply a number by its reciprocal, you always get 1. going back to the definition. This is different than the definition. This is applying reciprocals to actual problems. Do you know what I mean? Okay. Anyone else? Okay, let's go on to our first example without the definition. So example 1, first thing I want you to look at, if you notice a negative in the middle of a fraction, what am I going to tell you to do? What do I always tell you to do? Amberly. Good. Cross it off, put it with the numerator. The reason I have you do that is so that you don't forget about it, especially if you cross simplify. Okay, so we have negative 3 over 7 divided by 6 over 11. So keep, change, flip. Step 1, keep the first fraction, so negative 3/7. Step 2, change division to multiplication. Step 3, flip or take the reciprocal of 6 over 11. The reciprocal of 6 over 11 is 11 over 6. So keep, change, flip. Now, we did this yesterday and the day before. So now we need to multiply. We can cross simplify here. Alexis, what can we cross simplify? Good. Negative 3 divided by 3 is, we'll do negative 1. And then 6 divided by 3 is 2. So we divided both by 3. We can cross simplify there. We now need to multiply across the top, across the bottom. Yes, you're still dividing. You just have to change it to multiplication. Negative 1 times 11 is negative 11. 7 times 2 is 14. The negative at this point can go with either the numerator or denominator or in the middle. Questions on that one? Okay. Oh, I thought you had your hand up. Okay, everyone okay? Okay, let's go to example 2, and let's look at letter A, and then I'm going to have you guys try some on your own. Okay, so mixed numbers. When you're dividing mixed numbers, first thing you need to do is convert them to an improper fraction. So step 1, convert them to an improper fraction. 2.5 becomes 5 over 2. Rewrite your divided by. I want you to make sure that you open up your parentheses because the negative 3 3/4 is negative. Okay, I would then keep the negative with the numerator. Okay, so I'm going to put my negative there with the fraction bar. 3 times 4 is 12, plus 3 is 15. So this becomes 15 over 4. So all I did was take the mixed numbers, converted them to improper fractions. Is everyone okay so far? We can now cross simplify. Actually, no, not yet. Sorry. We now need to keep, change, flip, and then we'll cross simplify. So keep 5/2 or 5 over 2 the way it is. Change, so keep, change, flip, change division to multiplication. And then flip the second fraction or take the reciprocal of the second fraction. This becomes 4 over negative 15. I'm just going to keep the negative with the 15 since we flipped it. It doesn't matter if you'd like to keep it with the 4 instead. Your call. Okay? Okay, we can now cross simplify. Jackie, what can we cross simplify? Put 5 and negative 15, so 5 divided by 5 is 1. Negative 15 divided by 5 is negative 3. David, can we cross simplify anything else? Good. 2 divided by 2 is 1. 4 divided by 2 is 2. So make sure when you cross those off that you don't use the numbers that were already there. If something was a negative, please make sure that you keep the negative there. Okay, multiply across the top, across the bottom. 1 times 2 is 2, and then 1 times negative 3 is negative 3. So your answer is negative 2/3. Again, you can put the negative wherever you want, with the numerator, denominator, or in the middle of the fraction. Questions on that one? Okay, I want you guys and girls to try B and C. Okay, we've done 3 examples, including the definition. So I want you to try B and C, and then when you're done, just put your writing utensil down. Can I see yours, please? Good. Sorry. Let me know if you have a question. Oh, I want you to make sure you try that one again when you get a chance. Steve will be right there. Joseph, good job. You never have to cross simplify. No. If it's something that you don't like, that's fine. If you like it better to multiply across the top, across the bottom, and then simplify, that's fine. And guys and girls, that goes for everyone. If you don't like cross-simplifying, since you guys are 2 years advanced, I always give you the option. You don't have to do that. If you'd rather just simplify at the end, please just make sure that you are simplifying completely, okay? I like to give you options if need be. Good job, Kevin. Good job, good job. Good job. Wait. No, good job. I always forget you leave yours as improper fractions. Good. This one needs fixed, unless you just didn't cross-simplify. Oh, you forget to flip it. You forgot to flip it, that's why. Keep, change, flip is a very good motto. Try that again. This one. Good job. Oh, this one needs fixed. Okay, but this is right, so fix that other one. Good. That needs fixed. Keep, change, flip, Gio. So change them to improper fractions. Keep, change, flip. Okay, good. Oh, then you could have written on the notes. I should have told you that, huh? You could have written on the packet, but that's okay. It's all right. Good job. Good job. Good job. Did you ever learn keep, change, flip? Me either, until they told me last year. Yeah. Good. Oh, these need fixed. Did you do keep, change, flip? How'd this become a 24? Oh, here's why. When you're multiplying, you don't need to worry about common denominators. Okay, only adding and subtracting. All right, Nathan, question? Still needs fixed. So does that. You forgot to flip. Keep, change, flip. It should be, yeah. I just want to make sure we're going slow enough so you guys are okay with it. Okay, letter B. Let me write down the keep, change, flip part because some of you guys and girls made little mistakes. First thing, put the negative with the 5, okay? Negative 5 over 12. Change, so change division to multiplication. Flip the second fraction. So 5 over 24 becomes 24 over 5. Keep, change, flip. Please make sure that you're flipping or taking the reciprocal. Did you forget to do that part, Nathan? Okay, then keep, maybe you cross-simplified wrong. Negative 5 divided by 5 is negative 1. 5 divided by 5 is 1. You can also change 12 goes into both 12 and 24. 12 divided by 12 is 1. 24 divided by 12 is 2. Multiply across the top, across the bottom. Negative 1 times 2 is negative 2. 1 times 1 is 1. Any whole number always has 1 on the bottom. Any integer, I should say. So your answer here is negative 2. Nathan, did you find your mistake? Not yet. Ray, while Nathan's looking. That's fine. Yes, negative 2 over 1 is still completely simplified, so you're fine. You guys can keep it like that. Okay, letter C. First thing you had to do was change them to improper fractions. So the first one becomes 23 over 5. Just rewrite the problem for now. And the second one becomes 17 over 10. Now we do keep, change, flip because they're improper fractions. So keep 23 over 5, change division to multiplication, and then flip or take the reciprocal of the second fraction. Keep, change, flip. And then Skylar, could you cross-simplify anything on this one? Good. We can cross-simplify the 5 and 10. This becomes a 1 and this becomes a 2. You can multiply across the top, across the bottom. You get 46 over 17. And then did anyone convert it to a mixed number? Amberly, would you change yours too? Good. 2 and 12/17 is the mixed number. Okay, any questions on those? I know there weren't a ton of examples, but it's really not that bad. As long as you remember, keep, change, flip, like Steve said. Not that bad. Okay, let's do the word problem and then the closing. We're going to do this together. Okay, so here we have a problem about dogs. So it says you have 2 dogs that eat about 1 1/5 pounds of dog food per day. Okay, now be careful here. The question asks us how many whole days will a 5-pound bag of dog food last? So the question is how many whole days, not how many days. Okay, so what do we need to do here to figure out, first of all, how many days that's going to last these 2 dogs? Grace, what do we need to do? Not multiply. So it takes, the 2 dogs will eat about 1 1/5 pounds of dog food per day. That's for the 2 dogs. That's how much they eat per day. We want to see how many whole days 5 pounds is going to last them. Do not multiply. No, 2 dogs together eat, here's the wording again from your book. So now you got it. Together, they eat a total of, the word total should be in there, 1 1/5 pounds. Do you want to change what you said now? Yep, good. So 5 divided by 1 1/5. So I'll just clarify that one more time. The book meant here, the 2 dogs eat a total of 1 1/5 pounds of dog food per day. So again, there goes the book wording. Sorry about that. So we're dividing. Okay, it goes along with your lesson very well. Here's some application. If you want to figure out how much your dog or cat food at home was going to last your parents, right? You want to do that for them tonight? Figure out how long the food's going to last? No, probably not, right? Okay, so 5 divided by 1 1/5. Step 1 is change the mixed number to an improper fraction. So change 1 1/5 to 6/5. And then keep, change, flip. So 5 is just rewritten. Division changes to multiplication. Flip 6/5 to 5/6. Okay, Evan, is there anything that we can cross simplify? Nope. So multiply across the top, across the bottom. We get 25/6. We can convert that to a mixed number. Amberly, what mixed number is that? Good, 4 1/6. Now, the question asks how many whole days is that going to last? So how many days? Kevin? Good. 4 days is how many whole days, or how many days that 5-pound bag of dog food is going to last. That's not very long. Dog food's expensive. So only 4 days. These dogs might be fat or really big, right? Your cat is really fat. Do you feed it a lot? No? 30 pounds. What color is your cat? I'm just curious. Okay. Wow, that's a big cat. Okay. So you can almost put it on a leash and take it for a walk, huh? I'm just kidding. Okay. Aw. Steve? Yeah, you can do that. Yeah. Some of these, Steve, you don't really need a process to. Again, I'm just trying to be consistent with the book's definition. You can always use mental math, simplify, do things in your head. That's fine. I actually prefer that. Joseph? Okay. How does that happen? Because you will feed it breakfast and then your parents will feed him breakfast? Okay. Well, maybe you shouldn't overfeed him, right? Your dog whines, okay. So then you give it its food because it's whining. Okay. All right, let's do one more problem. Let's take a look at the closing. Okay, this actually leads really well into tomorrow's lesson. We're going to save equations with fractions for tomorrow. Okay, the last problem on there is negative x over 5 equals 14. First thing I want you to do is put this negative with x. So do you guys and girls remember from the end of chapter 3, how do we get x by itself in a problem like this? Oh, tomorrow's lesson might be easy. Mike? Okay, you can. Okay, you don't have to do that. You could. You could. Now, if you change this to 70 over 5, he's correct, but you don't have to do all that work. But that's okay, so hold that thought. Amberly, what'd you do? Good job. If you multiply both sides by the denominator, it will cancel. You'll get rid of it. So all you have to do is take the denominator, multiply both sides by that. Make sure that negative is still with your x, though. So we have negative x is equal to 70. Remember, multiply across the top, across the bottom. There's really a 1 here. You could also have 70 over 1 if you prefer that. Is everyone with me so far? Okay, so now we have to get rid of the negative. Drew, how do we get rid of the negative from chapter 2? Good, keep going. Okay, so you can either, there's 2 options. You can multiply both sides by -1 or divide both sides by -1. That's completely up to you. Okay, it's the exact same thing. In chapter 2, I always taught you guys and girls to divide both sides by the -1 to get rid of it, or you can multiply So you'll get the same answer. So negative 70 is the answer. This leads really nicely into tomorrow's equation lesson. Amberly? That's okay. Okay, hold on. Let her finish. It saved you a step. Yep, Neil. We're almost done. So if you guys and girls left the negative with the 5, that's fine. You can do that. It does save you a step. The only reason I moved it to the numerator is just to be consistent since I've been doing that. You don't have to do it that way. You could put it with the denominator, okay, as long as you understand how to do it that way. Okay, anyone else? Questions or comments? Very good questions today. Okay, I need you guys to open up homework packets of 5.5. Okay, okay, on 5.5, you don't need to do all of these. Okay, I want you guys and girls to try 1 through 12, 24 through 27, and, yep, it's up here, Steve, and 34 and 36. I want you to try two, well, basically one word problem, but one simplifying expression. Okay, so one more time, 1 through 12, 24 through 27, 34, 36. If you can do these, you'll be fine on this lesson. I always choose problems that are similar to what we did in class and also may challenge you a little bit. Keep, change, flip when you're dividing fractions or mixed numbers. Okay? Tomorrow we're going to go over this. Ms. Wingrove and I will give you back your graded assignment. We'll go over that if we need to, and then we'll move on to equations with fractions. Okay? Any questions for me? Okay, if you guys are okay, and once you have your numbers jotted down, it's time to get cleaned up. Make sure calculators are back. Girls are first today. You can put it back there if you don't need it.